Welcome everyone, and thank you so much for joining us today. My name is Ed Sandoval, and I'm the product manager for Aura Agent. I'm super excited to be here for this session, but what excites me the most is not what I have to say, but is what the folks from NAPSG Foundation and Leanmote have to say. We have a lot for you today. I'll kick things off with a quick overview of Neo4j Aura Agent. Then I'll hand it over to Kevin, Kay, and Jesse Osborne from the NAPSG Foundation. They're a nonprofit that provides geospatial tools to public safety organizations across the USA. Then we'll hear from Diego Giron, founder and CEO of Leanmote AI. Diego and his team are building a product that allows software engineering organizations to connect tools like Jira, GitHub, Slack into a knowledge graph. They use Aura Agent to power AI assistance to their user. And at the end, we'll finish the session with details of an exciting competition that we have for you. So to set the context, and for those of you not familiar with Aura Agent is a new product available in the Aura console that lets you build and deploy your AI agents on top of a knowledge graph in minutes. You can create the agent, add tools, and integrate it into your application with simplicity. In order to bring your Aura agent to life, you start from a knowledge graph. And this knowledge graph has to be an AuraDB. It doesn't matter what kind of graph you have, whether it's a context graph, memory graph, domain graph, a graph you build from unstructured data sources, a graph built from data in relational databases. It doesn't matter. As long as in AuraDB, you're good to go. The second step is that in the Aura console, you can create the agent, set it up with tools, and test it. We all know that an agent is only as good as the tools available to it. And for Aura agents, we provide specialist tools to retrieve data from your knowledge graph. Your agent can have three types of tools. The first one is parameterized query templates or Cypher templates. You can use these types of tools when you can anticipate the questions that your users will ask. Something like, give me details for this patient, or get me the details from this contract. The Cypher template will help your agent respond reliably, pulling precise information from the knowledge graph. The second type of tool is similarity search. This is your vector search tool. The user asks a question, the system finds the most relevant entry points in the graph, and your agent explores nearby nodes and relationships to build better context and hopefully richer answer. The third type of tool is the text decipher tool. You can use it for ad hoc questions that you cannot fully anticipate. This tool, the agent takes the natural language question, a fine-tuned model, and the schema of your knowledge graph, and generate a query, Cypher query, run it against the knowledge graph, and formulates an answer. And that's it. Once you've done adding tools to your agent, the next step is evaluation. Once again, in the Aura console, you can fire questions to the agents, check the response set, check the reasoning, verify all the tools that were invoked in order to answer every question. This is an iterative process. And eventually, once you're happy with your agent, you can connect it to your application in two main ways. You can use every Aura agent can be exposed as a Aura API REST endpoint. And with that, you simply get your app to interact with the agent via the REST API. And every agent also can be exposed as an MCP server endpoint, which means that you can use your MCP client of choice, Claude in this example, to use that MCP server endpoint to use the agent in your Claude work. And that's a quick overview of Aura Agent. But now I'd like to hand it over to people who are actually building their products using Aura Agent. So please welcome to the stage Kevin Kay from the NAPSG Foundation. Kevin?
Thanks, Ed. Appreciate it. I'm Kevin Kay. I'm the Chief Operating Officer here at the National Alliance for Public Safety GIS Foundation. I've been with local government and public safety for the past 15 years, and in the last 10 have really tried to explore local infrastructure and the connections amongst them. We do want to start out with a big thank you first to Ed and the Neo4j team for having us on. but more importantly to the public safety community, who is our main community that is using our technology. For those of you in and outside the US, this includes law enforcement, fire, urban search and rescue, EMS, 911, emergency management. And they use technology and data every day, from small incidents to large disasters. We've made a lot of progress in the geospatial space, but we see a new avenue of using graph database and graph data science to really improve their response to incidents and help the outcomes for both the responders and survivors. So again, that's our community we're building for, and thank you again for having us. Next slide. So a bit about NAPSG Foundation. Founded over 20 years ago. We are a 501c3 nonprofit. Our main goal is to empower public safety personnel with geospatial tools and other advanced technologies to better prepare for and respond to events. This spans multiple disciplines, spans multiple categories of building tools, training and exercise, and technical support. But more importantly, we, through the generous funds of both our sponsors and contracts we have with federal organizations, provide it all at no cost. So we're not selling anything, and we're a true neutral party when it comes to an R&D space for public safety. Next slide. So I just want to talk a bit about the gap and how we ended up here and talking about our local infrastructure network knowledge tool. We have multiple projects and multiple incidents that all uncover the same challenge, that local jurisdictions struggle to identify infrastructure, how they're connected, and cascading impacts. So whether it's from ongoing projects, world events where you see attacks on infrastructure, or even recent events here in the United States, such as the LA wildfires and Hurricane Helene, almost every incident has some sort of cascading impact related to utilities. And these are lifelines, water, wastewater, transportation, energy, hospitals, government. The struggle here is that in the United States, the majority of these are owned by private sector entities. So it's kind of difficult to understand what exists and how they're connected. Next slide. So there's definitely existing tools at the federal and sometimes state level. These tools prioritize nationally significant infrastructure. It's typically secured at a higher level. It's used for large incidents and used by those with vetted access. That is not what the locals are looking for. We've heard a lot of feedback that the locals want tools to, at a base level, identify what exists in their jurisdiction by certain sector and by a certain taxonomy, and then how they are connected. Then they could conduct outreach, they can do physical security assessments, cybersecurity assessments, bring them into their emergency operations center and do exercises to see how they would react to certain incidents. But that does not currently exist at the local level. Next slide. So again, that's the origins of Link. Jesse's going to walk through a bit of the technical side, but at the end of the day, we really want something that locals can interact with and make sense of their data in a easy to use way. Agents have allowed us to, in a plain language way, explore the complex nature of interconnected infrastructure. So with that, I'm going to hand it over to Jesse to talk about the technical pieces.
Great, thanks. Thanks, Kevin. Actually, can you hold off real quick, Ed? I'm going to give myself a quick introduction. Hi, my name is Jesse Osborne. I'm a data scientist and the lead architect for the Link project, or Local Infrastructure Network Knowledge web application that we've been developing that Kevin had, gave a good introduction to. I think the best way of being able to get to know and understand Link is through through seeing it in action. So I put together here a quick demo. You can go ahead and start the demo now, Ed, of just how easy it is to use Link. Simply just logging in, and you're immediately able to take action and ask questions in natural language. So Link uses Aura agents and an AuraDB instance under the hood. In this case, the users asked the question of, can you show me all of the power substations? The DB behind this has just a single county within Colorado. And as you can see over on the left-hand side, a number of key properties of the power substations. Over on the bottom right, a graph and a synchronized map to show the geographic context. User is able to follow up with some follow-up questions. Which one of these are connected to hospitals? Now you're seeing some real graph in play with these relationships, some of them being physical relationships. You can interrogate the data and learn a little bit more about all the different elements that you're seeing within the graph and on the map. The key point that I want to kind of hit home here is that when you introduce AI to the public safety community, they're not going to trust it right away. You have to earn that trust. And I think the best way to be able to earn that trust is to not just respond to their natural language question with a relevant response, but to actually show the data visibly, show them that and prove to them that this agent did not hallucinate. Here's the data that is associated with the response, and it's very tangible, and they can interact and interrogate it as at will. I think that's how we earn the trust of the public safety community, and as we move forward with more users hopping on board and learn more about the types of questions that they want to be able to ask and learn about their infrastructure networks and all the different interdependencies there, will evolve the system. At version 1, Link, like Kevin had noted, it is a free-to-use software, soon to be open sourced. And a key aspect that you want people to understand about Link is that Link itself is not storing data. The data will reside wherever you want it to, and in this case, our DB instance. What Link is doing is it's reaching out to that database and identifying, based on the language that you've asked your question, what are the key elements, and developing a Cypher query to pull out those elements and answer your question. And so under the hood, there's a pretty complex data model that has a number of different authoritative data frameworks, FEMA's Community Lifelines, the NAICS, Infrastructure Data Taxonomy from CISA, and all of that data has been organized in such a way that the agent can understand sort of the ebbs and flows of different supply chains across all of the different sectors: energy, wastewater, transportation, telecommunications, so on and so forth. The beating heart underneath the hood for Link is the agent, and so I'm going to hone in and focus on that conversation here. So next slide, please. From the very start, about a year ago, a little bit less than a year ago, there wasn't a lot across the tech community to easily build agents. There was some good stuff out there, and a lot of people claim to have all the answers. But in practice, there was some challenges and difficulties in custom coding these things. Admittedly, the first few iterations of our agents were not so great. Lacking in performance, lacking in quality, be able to respond to complex queries and questions. And it was hard. And I think, the day that I discovered that, hey, there's a little new feature within Aura that says agents, hey, I'll check that out. That was kind of a game changer for us because it made a lot of things easier. As you develop agents in a custom way, and it's not doing what you want it to do in the way that you want it to do it, you make slight little changes, and maybe you call that new version of your agent a different name. But it's a non-linear process. We found as we're iterating agents, they, on iteration number 4, all of a sudden, you start to lose quality in the way that some answers to questions are being exposed to the user. So with that, transitioning over to Aura agents, we found that it's a lot easier to iterate because it's all templatized, and I could really kind of focus in on the signal and filter out all the noise and focus on just the systematic instructions and such. Another great concept that I found new and novel, I don't know about everybody else, but it's Aura Agent separates the actual agent from the agent's tooling. And this was kind of a big thing because, as I discover more about how I want the tools to be developed, I'd have to constantly go back to all the different agents that I had in previous iterations and provide them the new tooling or updates to the different tools. And that was painstaking and hard. And sometimes, depending on how that agent was developed, there'd be little nuances to take care of here and there. But Aura agents made it simple. We were able to transition a lot of the tools that we use for semantic similarity search with our text vector embeddings encoded on the purpose and function of all of our infrastructure assets rather than the actual terminology being used. And Aura agents fully understood that and was able to operate and interpret that tooling in a good way. And we have a variety of other tools that perform complex queries against the knowledge graph to be able to pull out good answers for our users. And so glad the team is doing so much good work in this area because users ask a whole host of different types of questions, and we need to be able to have our agents answer those. Lastly, slide please. Lastly, the last point that I wanted to kind of hit is really important for to kind of set up and structure a valuation for your agents. As I mentioned, it's a nonlinear process, and we want to be able to understand, how each one of the agents that we have built in the past are performing against a number of different types of questions. So we developed a 25 question benchmark based on that are representative questions based on the types of questions that we expect from the public safety community, ranging from operational type questions to analytical type questions, and developing a rubric for how well those questions are being answered by different agents. And it's another area that I know Ed and team is passionate about. Looking forward to seeing more tools native within Aura to do these evaluations. But to date, it's been we wouldn't be here as fast as we got here without Ed and his team's help. So that's the last point that I wanted to make. If anybody is interested in contacting us, on the last slide here, Ed, we have our contact information. I guess it got moved, but we're looking for stakeholders and people interested in using Link in production. Please reach out.
Thank you very much, Jesse, and thank you, Kevin, and both of you for that very thorough and comprehensive use case and how you're using Aura Agent. And from the world of first responders and emergency management, we go into the world of improving software engineering organizations. So Diego, please come to stage and let's get started. Diego, you need to click on the button that says go on stage. There we go.
Yeah, perfect. Just got it. Okay. So thank you very much, Ed, for inviting us, and thank you very much for to the whole team at Neo4j. So, well, my name is Diego. I'm the founder and CEO at Leanmote, and well, we're using the technology to solve one of the critical issues that software engineering teams have. So if you move into the next slide, please. So nowadays, engineering tools don't talk to each other. So if you think about how a CTO or a head of engineering makes an informed decision today, they have to go into Jira Analytics, into GitLab Analytics, Cloud Analytics, and so on. So basically, what we have done is we have connected all the, we have mapped all the data points into the Neo4j graph database to solve this issue that there are 67% delays now in the whole in software engineering life cycle. We have understood and we have investigated that there is a 3-hour root case analysis, for example, and this problem costs 2.3 million in 100 software engineering team, 100 software engineering developer team. So next slide, please. So basically what we do is we connect all the productivity tools they use, we map the whole workflow, and we detect the bottlenecks that they have in between. So we uncover from when a ticket is assigned to someone until the code is in production. And we use Aura Agent to analyze all this data with natural language. Next slide. So I don't know if you have seen the pop culture matrix, but basically organizations are changing, products are changing, and what we do is we are more in the process side. So basically nowadays, if you want to make an informed decision, or if you make an informed decision, or if you change any part of your product or service, this will impact directly on your processes. So having a clear process and a clear overview and visibility will help you understand if every decision that you make will impact positively or negatively the organization. So how we use the Aura agent is, next slide, please. So basically what we do is we ingest the data, we detect the bottlenecks that they have through natural language. And for example, one of the questions, so you can ask simple questions as, for example, are my senior software engineering teams or engineers overworked with junior approvals, PR approvals? And you can get all this data. You can understand if that problem exists in your team or cross team. And you can, so we provide the visibility side of it where you can act upon. So this is really important because before we took a lot of time to understand and to analyze all this data. And nowadays, for example, we connect 1 month of data of a client. We found, for example, 100,000 relationships between teams, cross teams. And we're able to identify what's going on and if the problem exists in the team or in the organization. So next slide. Some of the results that we have generated for a client, we took a group of 20 engineers, and what we have uncovered is that after 6 months, they were able to increase 135% the throughput aside from the use of AI. So that resulted in an impact of, so that they were like delivering, like there was 27 engineers instead of 20. And this impacted the organization in annual saving revenue of $270,000. And if you go into the next slide, so basically, the only model that fits our solution, and we're looking more in the actionable side of things, is connecting all these, mapping the whole operational workflow across every tool. And the only model that we found viable is the Neo4j graph database connected with the Aura agent, because it provided us with exact results, and it was amazing the way we could plan action plans directly on Jira or connected to the different productivity tools. So yeah, it's time to stop using static dashboards, and we need to act more into or step into the resolution plans. Thank you very much, Ed, and yeah, happy to connect with you all on LinkedIn or email me directly.
Thank you very much, Diego. So let's recap and bring us home in the last 5 minutes. So what you've seen today is two very different teams, NAPSG Foundation and Leanmote. They started from a common point. They started from a knowledge graph stored under AuraDB. That knowledge graph is the source of truth, is the data that is in multiple systems and all of their relationships. This is what your agent uses to handle the questions. So step 2, they created an Aura agent in the console, and that helps power the natural language interactions with your graph. They define tools, test the prompt, validate the responses, all within the Aura console. And finally, they integrated their agents inside their UI or applications using the REST API endpoint. So that means that these guys can now focus on crafting user experiences that actually add value to their customers. We hope to have inspired you to learn more about Aura Agent and try it out in your next project. And if you want to do it, we have a cool way for you to get hands-on. Over the next 8 weeks, we'll be running the Aura Agent Hackathon. Taking part is very simple. All you need to do is complete the Graph Academy course, the Aura Agent Graph Academy course, before May 15. So you have 4 weeks for that. The first 500 participants get $100 worth of credits in Aura. Next, you build your Aura agent. Once you've gone through the basics and learned the basics, create an agent, be creative, take a data set of interest, one that particularly focuses on lots of relationships, and we'll be looking at multiple qualities of the agent. So is the agent clear, the role, how useful the tools are in the outputs ultimately. And once you build your agent, you will have until June 15 to tell us about that agent. Share it in the Neo4j community, and there will be tons of cool prizes on offer. And please check the Neo4j community for all of the details in this hackathon. But the first step is complete the course, learn about our agents. And finally, thank you very much for joining us today, and thanks to our speakers, Kevin, Jesse from the NAPSG Foundation, and Diego from Leanmote AI for sharing how they're using our agents in their products today. So I guess we can take questions if there are any. Don't see any on the session chat or messages or Q&A. Q&A. Oh, yes, Q&A. To build an agent, do we need to create data, or are they already a few data sets? No, you do need to create the Aura agent and the knowledge graph. They don't come pre-set with the agent, but there are multiple ways of creating a knowledge graph. If you have unstructured data sources, you can use the Neo4j GraphRack package, for example, or you can, if you have data in relational databases, you can use the data import facility in Aura to pull that data from relational databases and create a graph. And you can also use any of the Neo4j drivers to programmatically create a graph. Are these Aura credits for people who completed the Academy course? Yes, the credits will be for the first 500 participants to complete the course. And I think we're running out of time now, Malcolm, so I'll hand it back to you. And we'll do our best to answer the remaining questions in the Q&A offline. So thank you for joining us.